All right, well, let's get started. So first and foremost, I want to welcome everybody here. This is a new Meetup series that we're starting. And for everyone who's listening in the MLOps community, my name is David Aponte. And let me just preface what we're trying to do with this new series. So my man Demetrios has been killing it, man. You know, he's been doing such a great job interviewing some really interesting people, learning a lot of new things. But we decided that we wanted to dive a little deeper, to get into some of the technical details. And me working as an ML engineer, and pretty familiar with those details, and thought it'd be a good idea. Let's start a series and let's do a deep dive where we could see, where we have the opportunity to interview some people and hear how they're dealing with these MLOps problems and hopefully poke a little deeper into the technical details. So that's why we're doing this. We hope that you guys enjoy this new series. We'll be doing it more frequently, interviewing lots of awesome people. And yeah, and let me get started. So my name is David Aponte, and I work as a machine learning engineer. And I recently joined this machine learning ops community and have really loved it. It's been just so much fun to meet other practitioners, to learn from them, to hear about what they're doing in this space. And we're just really excited to start sharing all these best practices, all these learnings that we have, and try to provide a platform, a space where we could really just talk about these things and get past the hello world examples that we often find. And so today I have the pleasure of interviewing machine learning architect at Paperspace, Misha Kutsovsky. And my man is super smart, super cool. And we have a really interesting episode for you today. So we hope that you enjoy this. So first, let's introduce our guest. Let's introduce Misha. So tell me a little bit about yourself, Misha. What do you do at Paperspace?
Yeah, nice. Thanks for having me on here. It's going to be an awesome chat. So yeah, I am senior machine learning architect at Paperspace. So I kind of have like a hybrid role of working on the product and kind of making sure that kind of the features and capabilities that we bring in are kind of what machine learning engineers need, and to be able to quickly and confidently build and deploy ML solutions, and then also kind of go in and engage with a lot of our commercial customers on helping them really scale up the way that they do machine learning and take advantage of Paperspace.
That's awesome. And before we even get started with what Paperspace does, what is Paperspace? I think like it seems like you guys can do so many things. And what's your understanding of what you guys do? Like, how would you describe it to someone who knows nothing about this stuff?
Yeah, the easiest way is basically we try and make it really easy for people to take advantage of compute accelerators, mostly GPUs. And so we kind of have been around for about 5 years now. We started off doing GPU-backed VMs, a lot of things for VFX, for CAD, for gaming. And so we kind of have a whole product line around that, which is kind of, and we try and make it as easy as possible and have a really clean experience around doing that. And then we had a lot of folks that were using us to do machine learning. But when you start getting into the machine learning world, there's a lot of things that just being able to SSH or stream a VM isn't really sufficient, because you kind of have machine learning terminology around experiments and models and hyperparameters and deployments. And so we tried to kind of apply a kind of serverless and MLOps approach of developing and deploying your machine learning solutions. And so we've kind of been focusing in on kind of that area of the product for the last couple of years now.
That sounds awesome. I love making it when people make things easier. I'm sure a lot of us engineers and scientists, we really appreciate that too. So that's awesome. And I guess you kind of started getting into that, but it sounds like the main problems that Paperspace was trying to solve was originally not machine learning, but it ended up going into that, I guess, as the demand started increasing. So can you tell me a little bit more about the background story of how you got into that? I know you started touching upon that already, but maybe you could dive a little deeper.
Yeah, definitely. So we basically had this kind of VM-like product, and then a lot of folks were using it to run and develop machine learning models. I mean, we're all super familiar with kind of the compute requirements and the scale requirements that you have with parallelizing workloads and kind of having a job runner-like architecture to be able to kind of work on your code and then have it execute magically in a different place, but be able to kind of see what's going on, dive in, track it all. And so we started off kind of releasing Job Runner, and kind of our community edition product is really just around making notebooks in Jupyter Lab, Jupyter environments are really, really easy for people to take advantage of. And so that's kind of baking in the containers, kind of making it so people can share and have public projects, and really just in a couple of clicks to be able to go in and launch a notebook that has all the workspaces, that has a persistent file store. But then a lot of our more like sophisticated and enterprise like customers have a lot of other needs in terms of scaling out, doing distribution.
Sure.
Really, how do we go from notebooks into deploying and productionalizing machine learning apps and kind of the whole slew of problems, as well as kind of needing to run that in their own infrastructure. Kind of you have to run the compute where the data is, and to be able to kind of very quickly scale up how many models you're producing, how many, just kind of the life cycle of each of those.
Yeah. Well, I will say that from my experience playing around with Paperspace, it is really easy to spin up a notebook, and I love that. I think maybe some of you guys heard about Paperspace through some of those courses. What was the name of that course, Misha? It was, I think.
Yeah, fast AI.
Yeah, exactly. Yeah. So it is super easy, and that's awesome. And so it sounds like as you guys were developing, I guess, these solutions, you started thinking about yourself as a company, coming up with some sort of vision and things that you guys care about. What are some of those things? What does Paperspace really care about?
Yeah, so one of the things that we like very quickly, I mean, kind of the background of the company is a lot of just very traditional software engineering, infrastructure management, and kind of being able to bring a lot of those types of best practices and methodologies into kind of the machine learning world. And so I'm super excited to be here on the MLOps podcast, because those are kind of the things that we think of very deeply around what does CI/CD and machine learning mean? Like, what does a good MLOps hygiene, like what happens when you are able to confidently and quickly research, scale out, deploy, and really kind of what are all the gotchas that happen, and how can we as like a platform company be able to get the right abstractions for people to have like a safe of like rail guards where you're able to kind of do really powerful stuff. And if you need to dive as deep as you need to the node, to the container, to a set of experiments that you're going in and launching, but also to be able to very effectively train and deploy these systems in a way that is not necessarily intuitive for a lot of people, especially ones who are coming out of, all right, I'm going to do some Kaggle competitions. I want to go through some Google collab or some, like, I see someone's repo that they did. It's like a new state-of-the-art model. How do I go and actually integrate this into like my company and provide like business value?
Yeah, that's what it's all about too, right? I mean, it's really about providing value to the organization. You can't just have some cool algorithm, some great notebook. I mean, if it's not shareable and we can't provide that value to the users, it's pretty much useless, right? Exactly. And on that note, it sounds like you guys are coming from a lot of experience. It sounds like you guys have an engineering culture. You think about these things like developing the right set of abstractions, exposing the right amount of functionality to the user, and providing just enough configurability so that they could poke around and see what's going on, but also just get running nice and easy. So can you tell me a little bit more about your engineering culture? I mean, some of you guys are building these tools, right? What informs the way that you guys build your tools?
Yeah, definitely. We spend like a lot of time kind of making sure that we have the right abstractions, both internally as well as how we surface it to users. Like basically kind of a couple of our tenets, I think, are around making sure that you can do whatever you want, but also make it really easy to do the right thing. And so that's kind of like we're building on top of Kubernetes and Docker, I'm sure, as most other companies are, but then it becomes super interesting from kind of the product-y perspective where you can do whatever you want. And so you can kind of be running a job that opens up an SSH server and you can go in and connect into it. And so we have power users that abuse the platform in all these crazy ways. And our job is really to see what are people trying to do, and can we take those things and bring them up as extremely easy first-class components that other people can very easily take advantage of and benefit from. So it's like, okay, I'm spinning up tensor boards. Okay, can we make that easier? I want to go and scale up to do distributed training. Okay, can we make that easier? I'm spinning up various types of endpoints from TensorFlow serving, or my team is making all these different types of models. Can we automatically capture and track and version those and make it as simple as possible to deploy those as production endpoints? And so you can do everything on top of just a container or a web app that's running, but that's not really what a machine learning engineer should be doing. So like from our perspective, we want to let people do as much machine learning and machine learning development and not really have to dive deep and start dealing with Kubernetes YAMLs or Docker files, or kind of basically just focus on the machine learning code and the machine learning application and be able to go really quickly to business value.
I love that. I think you said so many good things there. One thing that maybe I'm parsing that out, but you were saying it sounds like you're developing your software when using the user stories, these use cases, how someone is going to interact with this thing, and then building something to meet those needs. I don't know about you, but I often feel like, at least with the stuff I'm reading out there, it's like people come up with a problem or they have like a solution and they're trying to find something that solution works for, rather than what's the problem, what do we need to solve, and how can we build something around that. So it sounds like, yeah, that's awesome. I love that. And I've always been curious, as I was looking at the website to kind of poke around the documentation. I would love to know a little bit more about like the infrastructure that you guys are using to develop your products and services. So without divulging any secrets or anything, can you tell me a little bit about what you guys are using to code and build?
Yeah, definitely. So I guess kind of we are maybe from kind of companies that offer these kind of like machine learning ops solutions. We definitely are different in the sense that we also have 4 data centers where it's mostly all GPUs that are inside of them. And so we kind of have an element of our infrastructure, which is running and managing data centers for kind of the hosted Paperspace cloud version. But then we also need to be able to go in and deploy into other customer environments, whether that's on-prem, onto new servers, AWS, or kind of, and to be able to really facilitate kind of multi-cloud workloads. And so we, in terms of kind of the Gradient product, which is kind of the serverless machine learning experience, we do a lot of kind of Kubernetes. And so our product is kind of built on top of the operator framework. And so we do a lot of Terraform to go in and configure and deploy and administer that. And so we recently actually open sourced an installer for the Paperspace processing.
Oh, nice.
Yeah.
Does it have a name?
Yeah, it's kind of it's called Gradient Installer. And so it lets you say, if you have like a GPU underneath your desk, it's a pain to set up CUDA, Docker, make sure that you have good machine learning tracking, and so really kind of make it as one click as possible to go and run this against your local machine, and then be able to manage it from kind of a centralized cloud console. So a thing that's maybe a little bit interesting about the way kind of Paperspace is architected is it's kind of split into 2 separate parts. So we kind of have our hub, which is really kind of where a lot of those like centralized services and API run. So kind of when you go to paperspace.com and you navigate into your project, you're viewing kind of a hub that we go in and manage, and then you can choose when you run workloads where you want to execute them. And so we kind of pass the request and the state across those 2 different locations, but that lets you kind of have multiple processing sites depending on the requirements that you have. So whether that's kind of different regions to be compliant with laws, like if I'm in Germany and I want to set up where all the workloads and data lives there, or if I want to be able to easily migrate from my on-prem to a public cloud, you really kind of have total portability of where the workload runs, but you're able to kind of work on it in the same kind of integrated and unified fashion.
Man, that sounds awesome, and also tricky to orchestrate. I'm sure that you guys are working really hard to make that super easy. But yeah, I didn't even think about that. Yeah, like across different geography, right? Like, I mean, you could be you could have I guess using an instance from a different country in a different region. So yeah, it's important to think about that. Well, you already started getting into some of the services that you guys provide, but let's get a little deeper. I'm sure a lot of engineers want to know, how can I use Paperspace? What can I use them for? And so let's talk about what sort of infrastructure or tools or services do you guys provide?
Definitely. So as I said earlier, I think we try and provide kind of these building blocks that let machine learning engineers be as productive as possible. And so that kind of starts off with kind of managed notebooks, which is the way that we do it is slightly different from the way that kind of you have like a managed Jupyter Lab environment. We kind of provide single Jupyter instances that have their own persistent file system that is shared across the team. And we do things like Docker snapshotting and basically let you fork and share kind of the container with Jupyter. So it also lets you easily go in and run something like VS Code. But basically a thing that lets you use the cloud to develop and iterate on your code. So you're going in and kind of developing on a subset of the hyperparameters, a subset of the data, making sure that your model compiles. And then the other kind of more like job runner experimentation component is how do I go from kind of like if one of the mistakes that we see people make is to actually do all of their production training inside the notebook-like environment as well. Like when you're doing that, you're not really taking advantage of one of these like managed cloud provider APIs. You want to be able to like take whatever you're running in the notebook or locally, and then be able to kind of package it up, zip it, or kind of reference a commit, and then have that actually go in and execute and orchestrate and kind of provide all the metadata. So we kind of have our job/experiment service, which lets you submit something as simple as, here's the local directory that I'm working in, or here's a commit that I want to be running, here's the type of machine, how many of them, here's what I want to be running. And then all of that gets orchestrated, auto-scaled up. And while it's executing, you have kind of real-time visibility on the logs, the metrics, the metadata, and
super important.
Yeah, super important. And then of course, with the machine learning world, you have the kind of nuances around tracking the data, tracking the hyperparameters, tracking like the machine learning specific terminologies. And then, so we do things like automatic model, model tracking and artifact management. So we build up a model repository for you for free. And that's kind of seamlessly integrated into the last part, which is really the inference service. So really allowing you to kind of take those models that you're building up that are kind of getting persisted into an object store, and then being able to serve them and update them with no downtime. And so really kind of those three parts of doing my research, scaling up my experimentation, doing my inference, but being able to really do that with whatever container framework you choose, and not needing to deal at all with any of that underlying complexity is really valuable for people that are kind of trying to just do machine learning in their company. So how do you really quickly go from trying out a new model to deploying a model? Maybe it's not the best one, but just getting that baseline up and running and having a way that you can know, is this new thing that I trained better? What happens when I do? And so the last part of this is we kind of have this thing called gradient CI, and so this is kind of the MLOps community. And so this is the kind of stuff that I'd love to dive in deeper on. But the ability to, when I check in my code or when I open up a pull request, we actually can automatically go in and kind of make a request to running or launching a set of experiments. And the result of those can kind of be the criteria of, does this model perform better or not than some baseline or than the existing one, and automatically approve or deny the PR. So kind of enabling you to kind of have the model development and model validation as part of the development workflow. So you can use Paperspace without ever touching Paperspace, but oftentimes you want to be able to have a nice UI and be able to visually compare things, but you can kind of, whatever workflow you or your team has, we can kind of try and fit into that and let you go in and develop and deploy these models very effectively.
Man, that sounds, there's a lot to parse out there. I love that last part about the this continuous integration. But you know, it's definitely much more than just a notebook service, right? You know, I think that for some reason that's what I thought Paperspace was like. It just offered notebooks, but it's much more than that. You can allow for any sort of jobs. You could service that or deploy something. That sounds really awesome. Now, can I dig a little deeper into I guess maybe the job component? So can I use custom images? Can I point it to maybe let's say I have a GitLab registry. Can I use images from there? How configurable is the containerization component?
Yeah, definitely. So all of the workloads kind of run with a container. And so you can use, so we provide kind of a set of like recommended containers for various parts, like you're using deployments, like use TensorFlow serving if you have a TensorFlow save model. We have things like Fast AI or Hugging Face Transformers as some like starter notebooks that you can use, but everything you can bring your own container registry, bring your own container for everything from notebooks, jobs and experiments and deployments. And you can kind of configure the repository that you're working on. So you can, again, have it be a local directory. So I can just be running, execute it, we'll zip up your local file, ignore files, and kind of automatically sync that into the job that gets scaled up. And then also allowing you to kind of reference any branch or commit from any source control system. So if you have GitLab or GitHub, you can go in and reference any kind of standard Git interface.
That sounds, yeah, super, I think really helpful for, especially for companies that would like to use Paperspace, right? Oftentimes you have maybe your own private code base and you want to use your own registry. So it sounds like it'd be really easy to plug in and use. I love that. Now, a question I have is about these jobs. So you said that it automatically scales, right? Let's say I have some specific requirements. How easy is it for me to tune that to maybe spin up more resources or use less resources?
Definitely. So we like underneath the hood, we kind of take advantage of Kubernetes and allow kind of some of the auto scaler APIs that you have there. So when you set up the cluster, so like if I have an on-prem instance or I'm configuring this in AWS, you can we have this kind of higher level concept of like machine type. So you can during setup be like,
Okay.
here are the type of machines that we have that correspond to certain like resource sets. So as I'm going and I'm doing workloads, it's like, okay, I just want to give me a C5 or give me a P2X large or give me a Paperspace P6000 machine. And we'll go in and kind of pick that node, scale it up, pull down your workload, kind of mount, do all this like file system mounting and volume mounting to that, execute the workload, crucial. And then basically free that up for another workload to occur. So we do things like job scheduling and data orchestration for these workloads to kind of make sure that the data that you want is available, that your code is there, and then you're running on the appropriate machine type.
That's awesome. So I can just choose the machine that I want. I'm sure I could configure the resources. Do I have access to the specific resources that my container will be using? Or how, yeah, like my question is how configurable is the machines that I'm using?
Definitely. So I think it's important to kind of talk about it from like two different perspectives. The first is like the team or like the administrator of the kind of Paperspace deployment. So there's a lot of configuration that you can do when you're building up the kind of cluster or deploying Gradient into your environment. And so there are things around like, all right, let's set auto scaling limits. Let's set kind of the type of machines, like how we want to go in and tag them, like kind of have like some smaller, medium, large GPU type instances that I can run against. But then there's the other part from the user's perspective. When I'm developing the machine learning systems, you actually don't necessarily want to be dealing with some of those details. So kind of, you can really simplify a lot of the cognitive complexity for people around, okay, I want to run this workload, give me this type of CPU instance. And so you can see, and there's like feedback on what's the CPU, what's the memory utilization, like am I getting IO bottleneck here, like what do I do?
Yeah, exactly.
So you really transition and make that adjustment, but you don't really want to kind of be necessarily always passing in, here's like a resource set that I want to have. So kind of, you can configure those based on what you want the people in your team to do. But as the ML engineer doing it, it's like, that's a lot of extra thought that you have to put in. Yeah. Just let me click a button and then get the type of machine or set of machines that I need.
I feel like the site reliability engineers in my company would love that because that's what they care about. They want to know, how can I set this up to make it as easy as possible for the users? But also at the same time, for the people that don't care about it, I just want to use it. It should kind of fit both of those needs.
Exactly. Yeah. So we oftentimes have to deal, or not have to, but we get to deal with kind of both sides of the machine learning initiative inside the company. So it's like you have the data science or the head of data science or the machine learning engineers themselves, but oftentimes kind of as part of our engagement, we also work with the SRE or the infrastructure or the actual engineering team, who usually kind of before we come in, there was kind of I build the model out and then I hand it over to them and then they go in and deploy it. But really, you kind of bringing those disciplines together is really, I think, what MLOps enables. And so kind of enabling, like kind of having a contract or a language that these two teams can interface on. And ideally, you can kind of enable the infrastructure team's life to be way, way easier, where it's like, this thing is deployed, it works, I can adjust or tune it. And then the ML engineers are just like, okay, we're totally empowered to run on the resources that we're given. I can go in, scale up, scale down, kind of the team admin can see how much money are these people spending, that kind of I can group them by projects. And then on the other hand, you also have, I can actually go in and just deploy the model myself. Like I can go bring this thing to the finish line and nothing's really going to get in my way. And so that's really critical to having a fast iteration speed.
That's crucial because, to be honest, it frees engineers and data scientists up to actually focus on what they want to do most, right? To do the actual machine learning. A lot of these details, sometimes they're like, man, I don't really care about this. I just need to do it to actually get my model into production. But yeah, it's I think the trade-off, right? You don't want to have, I know for us, we're dealing with this in my company where we want to allow people to have just enough what they need to actually get started and experiment and go from research to production fairly easily, but also make it easier for the lives of the SREs. Thinking about cost, right? Like, so recently we just had to reconfigure a bunch of stuff to make sure that we're using less resources and really taking advantage of a lot of serverless sort of architectures, because I'm a user. I'm just doing stuff. I'm just, all day, running models, not without a care in the world. But, the SREs are like, man, you're spending too much money, bro. And I think it's really important that you guys cater to both of those use cases, right? And I'm sure that people listening out here are thinking about, what can I use at my company to make the life of my data scientists easier? It sounds like MLOps is definitely a top choice, guys. So keep them in mind. And while we're on the subject of what you guys have to offer, I personally love building tools. That's what I care about. I love building on top of things. And I always love a good software development kit. I love when some service exposes it in Python or Java or whatever language that I have the freedom to build on top of. So can we talk a little bit more about the SDK and what it's like to build products on top of Paperspace, or with Paperspace maybe?
Definitely. So we kind of have a UI that kind of you can use to go in and provision whatever workloads or query whatever metadata you want. But the primary way that people actually go in and develop against this and do the level of automation is with kind of a gradient SDK. So you can basically do pip install gradient. You go and pull down this package. It kind of has both like command line, and you can kind of use YAML or just pass in flags as you execute these calls. But then underneath the hood, it uses this SDK, which is very Pythonic in nature. So it kind of makes it very easy to chain the outputs of previous steps into inputs of another. So I can very easily do a little wrapper function and do very sophisticated early stopping mass experimentation. And so kind of treating these building blocks as kind of, you can run whatever type of things you want, whether that's a single node job or scale up a deployment or stream the logs or the metrics of a deployment or a running workload, but then also be able to do the things that you need to around, is this system performing well? Let me go in and spin up a tensor board or kick off a bunch of experiments, add it into a tensor board, be able to compare these against each other. So there's a lot of picking what are those primitives that we want to surface as these like first class entities, and really provide like top line CLI support. So kind of autocomplete built on top of Click. Like there's like building good command lines is pretty challenging. We think we have a pretty clean one. It can be a little bit verbose sometimes, but that also provides a lot of benefits. So you kind of know exactly what you're going in and executing, and you have the ability to also automate a lot of that stuff, either kind of with dictionaries, with YAML. And so really kind of set up like a base config, make a couple changes on it in a loop and launch all of that. And so really being able to click a button and then have a request get made to the Paperspace API that basically to you, it just does magic. It kind of takes this workloads, does your training, you're able to see it and track it. And once you're all done, you're able to go in and kind of see, okay, what is this model that we produced? Let me make a decision on deploying it. You kind of have a very clean flow of like, let me launch some training jobs, let me check all of these, grab the best accuracy for the one with the best like F1 score, blue score, whatever metric you're using, and then be able to kick off a deployment. And then that deployment could be a staging one, and I'm going to go in and do my load testing, do my kind of out of sample validation, maybe run it as like a shadow deployment for a couple of weeks, and then make the decision to update the production endpoint that we have. So you're really able to configure the workflows however you would like.
That's super important. That's the type of stuff that I care about. And something I'm thinking about too is that what I like about this is that it allows me to build abstractions on top of that. So let's say if I'm building something in my company, I have that I could build something on top of this, allow my some software have just the core business logic of what I'm doing, and it has nothing to do with what Paperspace is doing. Yet I can still utilize it to quickly do some of these things. I think that's super important. And I'm curious, was the CLI battle tested by a lot of the people in the company? Did you guys just test it in-house to see how it works?
Yeah, I mean, so the CLI has been around in a couple of different forms for a long time. So like we kind of had we have like a node CLI for kind of a lot of our like VM management and kind of desktop embedding stuff. We had some customers that built out a C# version of it to kind of integrate into their workload. But for kind of Gradient, we've kind of really been all in on kind of the Python SDK and CLI version. And so, yeah, there's a lot of kind of load testing, actually just kind of using it, building out samples, running it kind of end-to-end test suites, validating all of the use cases. But then a lot of it is kind of talking to customers and using it and listening to what they're saying. So a lot of the stuff we try and bring in is kind of based on what people are saying they would like, or just kind of
just about
what pieces of code people are building on top of the command line often is like, okay, this is something that we should just make a nice little util function around.
Yeah, I was just about to ask you that. Like, how are your customers typically building on top of Paperspace? And this is just so I'm clear. This is just for Gradient, the CLI, or is it also exposed to other functions?
You can spin up VMs. You can.
Oh man,
it's kind of the full platform. There's a ton of
just for the command line.
Ton of capabilities in there. Yeah.
I love that. I'm a command line freak. I find it. I'm trying to get better at it, but it definitely is my thing. I love. I can quickly just from a terminal. I feel so cool when I'm doing it too. But that's awesome. And are there a lot of companies that are building on top of this? In your experience, again, you don't have to expose specifics, but it sounds like is it, or what's the how do people mostly interact with Paperspace? Is it through this sort of building their own products with the SDK? Is it from the UI? Is it a little bit of everything?
Yeah, I mean, I think you're touching on like a super interesting question, which is just like, what's the workflow of kind of these ML engineers? And honestly, like, it constantly shocks me the kind of like the gambit of ways that people use it. Some folks are just like, I'm inside the UI, boot up this notebook, do some stuff in there. Some folks are developing in PyCharm locally and then going in and kind of launching their workloads against Gradient when they're ready to kind of scale them up or kind of have them be actually like a real run that's tracked in version. We have a lot of folks that kind of build their own pseudo platforms on top of it. We're obviously trying to make it so there's nothing that you really need to do, but kind of integrating with existing services that the company already runs is generally kind of the area where that building on top of happens the most. If you're kind of starting off from scratch, you kind of have a bunch of like bash scripts that are spinning up VMs that you're SSHing into. It's generally just like, wow, I can just like changing like a couple of lines of code, really be able to just take this training job that I'm doing and be able to orchestrate it. And I just like don't need to deal with a lot of stuff. And so there's a lot of folks that kind of operate at that level, which is just cool. I have this code. Now I can actually much easier train it. It's all captured. I can see what other folks are doing. I can easily deploy this thing, but then there's kind of, you can get deeper and deeper in terms of, okay, I'm training these, I'm doing kind of talks, I'm doing chat detection, and I have a bunch of customers. So now I have to organize, I have like the central model that I'm pre-training, like a large language model, and then I'm tuning it for my specific customers. And so how do I organize all of that programmatically in a way that you can view it from the UI, and so really kind of spin up dashboards to surface what's going on underneath the hood, but then also to still be able to kind of have a productive workflow. So kind of some components that get created that everybody in the company broadly uses. And it's really around the specific scenario that you're using for where that comes.
Yeah, so I guess it largely depends upon where the company is at, what level of maturity their machine learning infrastructure is. Because like you said, they could be starting from scratch, which to be honest, some companies are. They're really just at the starting stages where they're trying to figure out how to organize their data. They haven't even gotten to the modeling part. They're just trying to get their data in order. And I got to be honest, that's still not even a solved problem yet. A lot of these problems are just, they're ongoing, and we're still trying to find the best solutions. But this is a perfect segue into workflows. Let's talk about Paperspace workflows. I read this super cool article. I forget who it was by, but it was on your Paperspace blog. It was called CI/CD for machine learning and AI. So this is a hot topic, right? How do we continuously develop and integrate what we're developing into this production pipeline? How do we quickly change things? How do we keep track of all these changes? And how do we do this in a way that actually makes sense? So let's talk a little bit about the workflow of MLOps.
Definitely. And so I think I'm kind of, for the audience here, I'm sure most of them are kind of familiar, but like the nuances as you're going from a more like traditional software workflow, kind of CI/CD works really well for normal development. You're kind of, you have your code, you push it, it's built, it's tested, it's deployed, and that's kind of the very linear path. With machine learning, there's nuances around the data that I'm using, the hyperparameters or the configuration, there's different types of compute resources that you need to be running on, like a pre-processing versus large-scale training where I need 100 GPU, or I need to data gravity, I need to run the workload where the data is. And then, of course, in terms of the actual efficacy of this model, once it's like just like how well this model is performing, both in training and in an online scenario. And so we kind of try and again provide those building blocks that kind of automatically do some of this immutability. Kind of you have a unique GUID for every step of the workflow. You can kind of dive in, view its logs, it produces metrics, but a lot of that kind of gets tied together into the way that I'm launching these things. So I'm just kind of declaratively saying, here's the resources that this workload is going to compute. Here's kind of how well the system did once it completed, and then be able to kind of make decisions based on both of those. And so having it get tied into the CI/CD workflow from kind of the source control perspective provides a really, really clean development flow. So I can either kind of in an ad hoc fashion run stuff. You still want to be able to run stuff ad hoc because you're, as a researcher, as somebody develops a model, having a first class just ad hoc run is really critical. But then you can kind of say, okay, I'm working off my branch, but then as this thing gets into master, then we're going to kind of do some other execution of this pipeline. So I can chain together multiple steps, or I can kind of have a couple different main production models that we're going in and executing. And if this PR passes, that means that the model was met our criteria for accuracy, and then we can then go in and deploy that.
That sounds, I want to parse a couple of things that you said there in particular. One about this pipeline, the CI/CD pipeline, and I'm sure a part of that is versioning. So how do you guys handle versioning, whether it be the data or the notebook or the job itself? Because you brought up a really good point. We want people to experiment. They need to do things in an ad hoc fashion. I can't always work in such a structured way, and I'm certainly not going to expect my AI scientists or data scientists to do that. But I want them to do it in like a safe way, right? In a way that I could help bring this to production a little bit faster or easier. So how do you find that balance between you allow the user to version everything so it's reproducible, but they also have the freedom to just play and just learn?
Definitely. And so a lot of that is kind of around making it really easy for people to help themselves. And so part of that is just like, if I want to look at what I did weeks ago, I want to make sure that I can do that. And then if I want somebody on my team or kind of another person to be able to collaborate with me, there's kind of a mutual contract that we need to have. And so the way that we generally think about this is whatever you're doing in your notebook is kind of, you can iterate, you can experiment, but the second you go in and kind of execute this in a kind of this serverless fashion, then everything is starting to get tracked, versioned. It is kind of in a way that somebody can fork the exact workload that you executed. And so really kind of you have your local, it's the same way. It's like I'm running in my local environment. Whatever you're doing there is totally fine. But then the second you're like, okay, this is something that is like a real, like I care about this and maybe something I need to run at a larger scale. The second you basically make a request that says, okay, I want to run this as a machine, I'm creating a machine learning experiment, or I'm creating a machine learning deployment, or I'm updating a previous version of an endpoint. All of those things are just kind of getting tracked with unique GUIDs and version histories, and are basically immutable objects that you can always go in and query down the road. And so it's capturing the hyperparams, the data buckets that you're using, the exact commit that you have. So we're kind of building on top of existing building blocks in the ecosystem, things like the object store API, things like the Git protocol on top of Kubernetes. And so we're really trying to just kind of bring the pieces together in a way that makes it really easy to have a really clean flow where people can speak the same language.
And you mentioned a couple of things like opening up a PR. What is that? What do you mean by that? And also forking. Can you like literally like fork someone's notebook and then kind of work off that same version, or fork someone's job?
Yeah, so you can do all those things. So from notebooks, we kind of, because we're kind of doing the actual, just basically it's a Docker container where you're running the service, you're kind of having a file system that you're running on top of. And then when you shut this notebook down, we're basically snapshotting the workspace, we're snapshotting the container. So if you're kind of in this notebook flow, I did like, okay, I'm doing a pip install, or I'm doing an apt-get. Like when I'm trying to get a new package or library up and running, I'm not always going to be able to have that in a perfectly reproducible fashion. But so the second you stop doing that, I'm able to fork it and kind of continue off and be confident that I'll be able to execute whatever I'm doing. But then there's kind of a forcing function for the user to, as I want to launch this as an experiment, I need to have either a requirements file or a Docker file that has all the dependencies for it. So there's like a force, there's kind of that channel of, as I'm actually kind of going from this notebook flow, I need to make sure that I can reproducibly execute my code. Yeah. And so kind of just having that function of, I'm doing whatever I want here. I have like random like bang pip installs in my notebook as I'm playing around or messing around with versions. The second you get it to actually work and compile, you can very easily go in and actually launch that as an experiment. And so all the workloads and jobs that you're doing, they kind of have their inputs, have their outputs all captured. And so you're able to basically just get the config of that notebook and then be able to change a parameter and then execute it.
Yeah, that's super important. So it sounds like you can, while you're researching, the user doesn't have to worry about the versioning. It's like sounds like it's already happening in the background for them. And when they're at that stage where it's like, okay, I have a good model, has the right metrics, now I'm ready to go to the next stage. All I have to do is just fork that, and now I can go into this next level of this pipeline, which let's talk about. So now I have my trained model. It's producing the metrics on whatever benchmark we have. Now what do I do? What else do you offer the user once they're at that stage?
Definitely. So I think there was a quick question that I want to make sure that we touch on before we kind of move on, but it's very related. Sure. So it's kind of like how can I make sure that my workload runs? So I use the word PR, but it's also kind of commit. So it's really, as new code enters my source control system, that's kind of one of the inputs that requires new training, right? I have new code, I have new data, or kind of my deployed model is kind of has some drift that occurs. So basically, when any of these kind of new events occur, it's kind of a reason to go in and launch a new training job. So when I use the word PR, I literally mean the word, I open up a pull request from my branch as I'm kind of developing, so you're kind of forcing all the machine learning code to go into a source control system. And then once I open up that PR, I'm kind of opening up a pull request saying, I want to see if this model that I'm training is going to be better than what we currently have in production. And then it will go in and launch and run this full machine learning workload that will kind of scale up the infrastructure
automatically.
Yeah, you can configure it that way.
Okay,
so that's kind of where you're going from. Because again, sometimes if you set it up wrong, you could just be blasting out like you're like, oh, commit message. Why won't this work? Why won't this work? You don't want to be running stuff then, but you can kind of configure it based on this specific requirement of like, if I have to tag it to do a training job. And so you can do it.
Okay. That's what I was just,
Open up a PR. I can have the same way that you have for normal, like Circle CI or any other of these kind of software dev CI systems. You can just say, okay, cool. This is what I want to try and run because I ran it locally. It compiles. And so you go in and you launch this machine learning workload. And this is kind of where what you said just now is really interesting, where it's like, so you train this model, it has some accuracy that you care about. What happens next? So the first thing that you really care about is this accuracy good? And so you can either you can have this model and then you're like, all right, what do I do with it? Maybe I want to deploy this. But if you're working in this kind of MLOps production workflow, where like right from the beginning, right when you're starting off in your notebook, you care about how am I going to get this to production right away? You can really just say, okay, there's a certain accuracy or threshold that I care about. And if this new model that I produce meets that criteria, then I'm going to have this build step basically in my CI/CD system pass. But you can also mean if you produce a junk model or something that's worse than what you currently have, you don't really care. So you'll kind of actually just fail the pull request. And so you can kind of bid into the actual source control system itself. And so we do some things that are kind of basically make it nicer. And so kind of publish a pull request report automatically back. So you can kind of build up similar things with like GitHub Actions and other things, but it's really just seamless as it integrates into kind of the Paperspace workflow and experience.
So you mentioned, so it sounds like there's automatic model validation of sorts. Can we talk a little bit more about that? So can I say, okay, I want a ROC AUC of, 0.75 at least. If it doesn't meet this baseline, then it's trash. Don't even bother moving it to the next stage of deployment. So how do you guys actually make that happen? Because that sounds pretty tricky. Definitely.
So for certain types of models where like we can kind of infer what's occurring from things like the checkpoints. So let's say I'm outputting TensorFlow checkpoints. So we go in and we do kind of an automatic aggregation over all of those. So we'll kind of auto generate the min, median, max, the standard deviation of kind of whatever metrics that you're going in and outputting. So you kind of have like an accuracy or loss, and you have a couple of pieces of metadata there. And so you can kind of index into, it's basically just you end up with a metadata JSON, and you can, based on any of the values that are inside of it, you can decide what I want this to be. So you can kind of make sure it's within a range or above a certain value. So there's kind of numerical comparisons that you can build into the CI system.
Yeah.
But then
That's
for
so
like custom
important.
models, you can also just output your own. So like as the person that's training the system, you can say, okay, here's how well this model performed. And when you're actually outputting the artifacts themselves. And so we'll go and we'll capture and track that, and you can have that be part of the CI system.
I can't stress how important that is, that there's like easy ways to sanity check the actual pipeline. I find that as I've been developing some of these tools for my company, it's not always the easiest, like to sanity check things, and there's a few reasons for that. In my opinion, I think like you mentioned, just like there's this data component, I have the model component, but then I have just this randomness that's a part of the training process. And all of this is very hard to manage and to sanity check in some ways. And it's, I find myself trying to find better ways to do that. How can I actually validate that? I've recently been reading more about that, but yeah, it's definitely something that I'm still learning about, but it sounds like you guys are already thinking about making that easier. And we talked a little bit about just being able to run a bunch of jobs and kind of get to this place where I can validate the artifacts at the end of that. But how easy is it to observe my metrics? You mentioned the UI, right? Is there ways to do that from the command line too? I feel like that'd be really neat.
Definitely, yeah. So we have, I think one of the novel things that we realize is that you care about metrics both while the workload is running as well as its kind of final state. And so all of the different workloads that we run on Paperspace, like I'm doing a training job where I kind of have a deployment. While those things are live and running, we're kind of building on, and we have an easy way to basically go in and export like custom metrics as well as like a default set of host and CPU, GPU, memory utilization type things that you can both view inside the UI as well as actually programmatically query against. So I can set up like in my code, I can be outputting certain metrics as kind of a time series of how many samples this thing is processing or what the shape of this data is. And so, and it's like coupled with the workload itself, and I can make decisions based off of that, both while it's running. So I kind of launch this workload and then I'm watching it. So I can watch its logs, I can watch its metrics, and I can make decisions based off of that. So like, I could see this thing going totally off the wall and I could cancel it early. So I can very easily launch this workload from my command line and then be just sitting there and be like, okay, cool, I'm gonna stop this thing now. It's not doing well. So it's even really useful in the experimentation and research phase to know how something is doing and if it's worth letting it run all the way through. And so you have that for both your jobs, for your deployments, and so you kind of have the final model metadata, which you can kind of use as the PR gate, but you also have runtime metrics. And you can command line SDK to pull those in, very clean, and then also the final state. Hey, this experiment produced a model with this metadata. But you want to have both options as you're making decisions around.
Man, that's excellent. And so, okay, we're in this pipeline. We have validated our model. It makes sense. It's producing metrics that are reasonable. We feel safe moving forward. I want to make it available to my users. So what does Paperspace do to make it easy to deploy? I have already poked around a little bit. I saw that you guys expose a model as a REST API. That sounds awesome. Can we talk a little bit about this last stage? Now we have something that we want to deploy. We want to send it out into the real world.
Definitely. So, and that's honestly one of, I think, the hardest phases for a lot of companies is really kind of to make sure that you're able to deploy. And so we try and encourage people to make sure that you are able to deploy the project that you're working on, even if the model isn't great, just so you kind of have the ability to take any improvements and instantly bring them into production. So we try and make that super simple in a couple of different ways. So we basically run an inference service that's kind of has some overlap with things like Selden or KF serving or other kind of building blocks, but it's really integrated and coupled with kind of the automatic model repository that we're going in and kind of capturing. And it has the lineage of this endpoint is linked to this model, to this experiment, to this code and this commit. So you can always see exactly what produced the model that was making predictions. And so we have a couple of different model types that we support. So I mean, you kind of have Onyx and PTH and TensorFlow, save models. And so for some of those, we basically try and kind of the same way we do for notebooks, where you just have a one-click option that I can just take this model, click it, and then it will go in and scale out and surface as a REST or gRPC endpoint. So you can do, for TensorFlow serving, for example, we're like using standard open source serving containers, but really packaging them up and kind of making sure that they'll easily work and expose their endpoints for users. You can also bring your own custom serving apps if you kind of want to deploy a Streamlit app or a Viola dashboard. You can easily kind of inference is really, it's just kind of it's like an overlay on top of the kind of Kubernetes infrastructure there, but we have things that allow you to update the model with zero downtime, caring about like how many replicas it has, and doing auto scaling based on certain criteria that are being kind of scraped out of Prometheus. So you can kind of very easily get like a real production endpoint available that you can update with as there are new models that are coming in, or as you have new inference code, or if you change some logging config, you can easily deploy those and experience kind of no downtime.
How easy is it to observe like the usage of these live endpoints? You mentioned Prometheus. Do you guys provide, I guess, the ability to point to your specific Paperspace cluster? Or maybe I'm not saying it right, but I guess, can I point my Prometheus instance to Paperspace and take a look at what's going on?
Definitely. So I'm not sure so kind of maybe it's worth kind of talking about the architecture a little bit more. So we kind of run our own hub site, which is kind of where the services, et cetera, are running. And so that's kind of where the API, the UI goes in and lives, but then it's pulling the data from kind of the processing site. So if, like I'm setting this up in my own AWS environment, we're actually going in and running some Prometheus instances inside as part of the Paperspace deployment, where all of these streaming and metadata is. So you have access to that, so you can kind of pull up a Grafana dashboard and view what's going on. But you can output your own metrics from your own code. You can kind of tie it into other existing monitoring services that you might have, like Datadog or something like that. But they're generating, and you can kind of, without needing to leave that flow, you're able to kind of know how everything is doing. And we're using that to kind of make decisions about, okay, should we scale this instance up or down? You can kind of have access to that same raw data stream. So you can kind of dive as low as you need to, but really the happy path is one where you're able to just focus on this machine learning model. Let's go in and, okay, we have this endpoint, let's load test it. Let's maybe validate how well it did with, like, we can run another job that will fire off a bunch of requests with kind of this holdout data set that we had that has a bunch of edge cases, or kind of just like have shadow traffic go in and hit it and see how it's performing.
Yeah, I'm actually dealing with this problem right now where I'm, thinking about load testing it, writing integration tests for my live endpoints, and it's definitely not easy, man. And now we're also taking advantage of Kubeflow, so we also are using serverless applications, and it's like it comes with its trade-offs. Like we love that it can increase traffic when we need it, right? When a lot of people are hitting that endpoint. But we ran into this problem where we're just trying to figure out, like, should we keep it on at all times with like a certain amount of resources? Should it be completely off and then turn off when the user hits it? We have also these jobs where it's not as simple as just taking in some input. Like we have to do some feature generation on the fly too. And so now we have latency concerns. So how easy is it to configure like the inference services themselves? If I wanted to use GPU to serve my model, can I do that pretty easily?
Yeah, definitely. So of course, assuming like all the ops are supported on GPU, but basically for all the workloads, if I'm in my notebook, I can very easily be running it on a CPU instance, stop it, relaunch it on a GPU instance, and I'm able to kind of continue right there. So it's the same way as like I can go in and use take my model, use like a CPU-based instance, like if I'm not doing anything that would benefit from a GPU, batching or any of these things, like you're able to kind of get by in a lot of stuff on CPU. Or if I've done some high level of like pruning or quantization, or maybe then I need to, basically like there's a lot of criteria where you need to be able to run on GPU, but there's also a lot of serving cases where you're totally happy with being able to just have a CPU endpoint. It's much cheaper. It's able to parallelize the requests and scale up, but you're able to kind of have total configurability over it. So we kind of give you the full underlying node that you want to run on. So you can have multiple models that you're being served that are sharing the GPU if you're using something like Triton. But for most of the time, it's really just kind of, you're running a container with NVIDIA Docker, and we're handling kind of the auto scaling group, the updatability, the downtime, like the lineage of what exactly it is that I'm serving. And we kind of go and work with people if they're building out their own custom serving applications. Like I know you had mentioned at one point that you guys are kind of dealing with, okay, how do I load test this? What does load testing mean for my endpoints? And it's very use case.
Yeah.
There's no like standard way that you can deal with that thing. And so we kind of see a bunch of different inference use cases. And so kind of how do you consolidate them into something that is flexible where it can support any user, but is simple enough for kind of the 95% of serving cases that we see.
You know, and usually that's what it really is, right? It's like usually like you said, a CPU is fine. You don't need a GPU for the most of the time. Like, yeah, it's nice, you know, but I think, yeah, for someone like me who likes to play, my play can be pretty expensive. And I've learned the hard way that, you know, using a CPU is just enough. And I'm good with that. Man, this is really awesome. I really enjoyed just kind of seeing this end-to-end infrastructure you guys provide. I mean, everything from starting at the research stage where I'm thinking about the right way to model this, and I can experiment, I can mess up, but I also don't have to worry about reproducibility because some of that's already done for me. Then if I need to spin up more resources and do even more complicated things, I can do that. And then if I want to serve it, I can also do that as well. So you really provide this end-to-end set of tools. And I think for anyone listening out here who's looking to find a good solution to setting up your infrastructure, I highly recommend you guys check out Paperspace because, you know, it's tempting to build your own solutions. I'm sure you talk to a lot of customers, and it is nice to build your own stuff, but you know, it sounds like you already have done some of these things really well, you know, and I'm definitely, I mean, we had an episode recently about that, to buy or build, right? There's always a trade-off there, but personally, I'm the fan of using what's good, what already works, and this sounds like it already works really well. So I'm looking forward to playing around with some of this stuff personally.
Definitely. Awesome. Well, hey, David, thanks for having me here, and huge shout out to the MLOps community in general. Like, we're all here solving a lot of the same challenging problems, and it's rapidly evolving space.
Yeah, and because it's rapidly evolving, you know, it's hard to kind of think about where things are going, but I'm curious to hear your thoughts on this. Where do you see within 5 years this MLOps, at least where it currently is, where do you see it going? And it could be as general or as specific, whatever you want.
It's a loaded question. I'm going to throw that back at you first, which is, I guess, what are you, based on kind of what you've seen on the ground, like, what do you think the workflow is going to be like?
To be honest, I guess maybe this is a cheesy answer and it's a cop-out, but it's a lot of what you guys are doing, making it easier to have, honestly, providing more abstractions to a lot of the things that I personally have to do on my own. You know, I'm comfortable working with a lot of like these tools, but I see that being less and less necessary. I see it, you know, maybe data scientists not having to know much about Kubernetes anymore or Docker or these things. But right now, at least where things are, you kind of have to know a little bit of everything to own that process. I anticipate within the next 5 years that it will be less and less of that as people start building better solutions to some of these common problems, you know. And right now it seems like there's a lot of things that are coming out, but it's still some of the tech that's out there is still not ready yet, still not, you know, able to be integrated to some of these companies. And I imagine that it's only going to get better, that things are going to get cheaper. I mean, that's at least the trend that I've seen. And there's going to be smarter utilization of whatever a company has in store. So maybe they have an on-prem cluster, maybe they're using the cloud, but using that in a better way. I think that we're trying to find that sweet spot of you know, like what the SREs care about. Are we utilizing the right amount of resources and meeting, you know, the business needs without being wasteful? And I see that getting a lot better. So and personally, that's my hope. I hope that monitoring and observability and traceability becomes a little bit easier, because right now, at least in my experience, a lot of this is being done by the companies themselves. You know, I know we're doing that. We're trying to figure out the best way to do that. But, you know, I think that people are really smart in this space, and they're coming from experience dealing with these same problems. So I imagine some people build tools, but exactly what those are, that's going to be a tough one. But yeah, that's my cop-out answer.
No, it's not a cop-out answer at all. I think you hit a lot of stuff right on the money. Like, I feel like, so we never really even kind of define what MLOps is. But like, from my perspective, like, really good MLOps inside of a company means that you're not actually dealing with any ops. Your machine learning engineers and your data scientists are able to develop machine learning solutions and be confident that they're going to be able to kind of automatically have them flow through and be deployed. And not need to deal with kind of these areas that are ultra time consuming. So it's like you have these tools that kind of solve different parts. They're kind of fractured all over the place. And really, the second you need to step in the kind of like look and dip your toes into the infra opsy world as a machine learning engineer, as a data scientist, it becomes really hard. Like, I think like the amount of machine learning pipelines, the complexity of them is going to be probably a couple of orders of magnitude more than we have today. And we're going to be flowing across different clouds based on price. We're going to be like, it's like Kubeflow, Airflow, like all those things aren't really going to matter as much. I think we're slowly starting to come to get to like what the right level of abstraction is. And people spend a lot of time on like the layers of abstraction for kind of the machine learning thing. It's like, okay, I have my training, I have my eval, I have my model architecture, I have my kind of test frame pulled out, and then I'm kind of firing along all cylinders inside there. But then you also have these kind of MLOps related things in terms of, all right, how do I get that infrastructure set up and orchestrated? How do I know that this thing is doing well? How do I even define what it doing well once it's in production looks like? How's all that plumbing set up and wired together? And I think that we're still not totally there, but like I'm kind of the buy or build thing. It's really it's worth any amount of money to be able to just focus on providing business value from doing machine learning. Like you see so much 100%. Value get created where it's like most companies aren't at that like totally saturated maturity level. It's like there are so many new things that you can unlock with machine learning, whether that's kind of existing data that you have, bringing in pre-trained models where it's like, it's literally just such a blue ocean area. And so you want to be able to just kind of explore that as quickly as possible. And part of that means not being kind of bogged down with either something that you had done previously not working and needing to spend weeks trying to kind of debug or make
that's my life.
Or kind of be able to go and actually just develop new systems and deploy them and know and be really confident that that's going to happen. And I don't really think that's the machine learning engineers are going to be doing a lot of that stuff. Like it's really almost MLOps is going to be its own specialty, the same way you have SRE, you have DevOps, you have just front end, back end. It's like that is a different area.
Yeah. I think that's a great answer. Absolutely, 100%. Like the way you said it is that like, basically I'll have to do less and hopefully other people will kind of form their own specialties around meeting some of these needs. And I think that's kind of good in my opinion, like, the separation of concerns, like let's try to do one thing and one thing well. And right now it kind of still is in this space where it's like, you have to do a little bit of everything. And I don't find it, the most efficient, but it's definitely getting better. Well, I think that's great go ahead. No, sorry, go ahead.
No, I was going to say like the other whole just kind of can of worms in the room is just like a lot of these things are kind of plug and play where it's like, okay, I'm going to try and do a hyperparameter AutoML search over this type of area, have like early stopping and really be able to just try lots of combinations and see what works best. And so like today we're doing a lot of that stuff on like the training side. It's cost expensive, but like that's dropping rapidly. People are starting to do like auto feature engineering. Like, of course, there's like the element of the human touch, but it's really, you're going to be working hand in hand with these kinds of tools, allowing you to solve more problems more effectively. And then from the infra and ops side, it's going to be a similar type of thing where it's like I said the word magically, it's like this thing runs and it's really, you want to think that you don't want to just say, I want to run this here. I want to know how it's doing while it's running and when it's done. And be able to make business decisions off of that, but I don't want to have to deal with what's going on underneath the hood. And so you're going to kind of have more of these end-to-end unified interfaces.
That sounds awesome, and I look forward to the future to learning in this awesome space. And let's close out on this. To everyone in the MLOps community, what are some best practices that Paperspace has learned throughout these years? And what would you like to share with the community? What's like one little nugget of wisdom that you guys have learned?
Yeah. Well, first off, I've learned a ton from following the MLOps, like both the Slack and various articles, kind of I think the community is awesome in terms of sharing pieces of wisdom in terms of tech debt where it occurs and kind of tips and tricks on doing inference endpoints or setting up training workflows or people posting cutter or sample projects that help you organize all of your code. And so I think that we've benefited a lot from our users, from the community already. And I think that's kind of the open source and sharing element that really is allowing this field to move so rapidly.
That's right.
I think talking with folks like you who are sharing in the ground experiences is always, always fascinating. I think kind of like the high level advice that we really have is just around, you want to be, when you're starting working, you kind of want to know how you're going to end up when you're done. And what I mean by that is just like, as you're starting off in your notebook, just kind of either having a standardized project workflow or kind of know how you're going to integrate with whatever managed platform you're using to run it, where you're able to kind of have a flow from research and know how it's going to trickle down into production and know what a healthy and good state looks like. And really just like if you're starting off with kind of those rail guards and kind of that idea, you're going to you're going to avoid all of these different mistakes. And kind of these platforms encourage these kinds of best practices. Like the general thing is like, I'm just running some code. It has some inputs. It has some outputs. I need to assemble a lot of those together. They do different things, but at the core, it's really, I'm starting off here on this business problem, just like what I define as like my end goal. It's like, I'm going to be serving these types of requests to this person, or these are my customers. And then let me just kind of make sure that I can get that baseline up and running. And then I can iterate on top of that. Because if you can just spend so much time over optimizing before you really get the end up and running. And so just don't over optimize too early. A lot of just kind of, there is an upfront investment in terms of evaluating ML platforms or making decisions about this tool or that tool. But at the end of the day, it's really, once you make that decision, you want to have it solve the problems that you have or that you will have in the near future, and then be able to just kind of do more machine learning, deploy these machine learning models, and really build really cool stuff.
I love that answer, guys. And I hope that you guys, for engineers, especially myself, I am guilty of over-engineering. I love building cool stuff and providing interfaces and frameworks, but you brought up a really important point. I hope everyone hears that you really have to frame the problem well. You have to think about where things are going and ultimately how to provide value for your organization. Machine learning is cool, but it's useless unless you can productionize it and serve it to your users. And I think, we heard amazing tools that you guys have to offer. I hope that for everyone listening, that you would really check this out. We're probably going to do a demo real soon. We'll probably play around with the SDK and run some jobs. And so stay tuned for that, guys. We'll show you how to use it. And please reach out to me or Misha. We're in the community. We love doing this stuff, and we're looking forward to hearing what you guys have to say. Awesome, Misha. Well, thank you so much for spending this time with me. I wish you a wonderful evening, and thank you so much for doing this.
Awesome, David. Thanks for setting this up. Super excited for future sessions that you host. And again, shout out to the MLOps community in general. I think they're top tier. I'm excited to be a part of it.
Awesome, man. Well, you guys have a great night. Take care, man. All right.